question 2 is just using the trapezoidal rule. It has part A, B, and that's it. So only 2 parts. So B says use the trapezoidal rule to estimate the area of the region enclosed. Okay, so we'll just use the trapezoidal rule. That's grand. And in part A, we look up from this plot what the values of f0, f1, f2 and so on are. So basically these are the things that we use in the trapezoidal rule. So we're going to get the height of this curve is f of 0 at 0, f of 1 at 1 and so on, and then we're just going to plug in these numbers into the expression for the trapezoidal rule. And we actually have the expression for the function. So we don't need to look up, we don't need to measure the value from our plot. We actually know the value of the function. So we know at 0, f of 0 is 0 because x is 0. So 6 times 0 is 0, 0 times 0 is 0, and so on. So we actually just need to evaluate this function at 0, 1, 2, 3, 4, 5, and 6. Once we know that, we plug it into the trapezoidal rule, and we're done. So our function f of x is equal to 6 of x minus x squared. We evaluate this at 0, 1, 2, 3, 4, 5, 6. So we'll just have x, that's 0, 1, 2, 3, 4, 5, and 6. So at 0, we have 6 times 0 is 0 minus 0, so that's equal to 0. When x is equal to 1, well then we have 6 minus 1, so that's going to equal 5. When x is equal to 2, we're going to have 12 minus 4, so that's 8. Check again because we have lots of time. I mean, this question is pretty quick. So when x is equal to 2, 6 times 2 is 12, minus 4 is 8. I mean, the only thing we don't want to do is mess up here because it'll only take a minute to do, and so we might as well get full marks. When x is equal to 3, well, 6 times 3 is, well, I'll write that out here, okay? When x is equal to 3, we get 18 minus 9, well, that's equal to 9. When x is equal to 4, we get 4 times 6 is 24 minus x squared is 16, so that's going to equal 8. When x is equal to 5, we're going to have 6 times 5 is 30 minus 25, so that's going to equal 5. And when x is equal to 6, we're going to get 6 times 6 is 36 minus x squared, which is going to be 36, so that's equal to 0. So now I'll plug these into the table. So when x is equal to 3, we get 9. When x is equal to 4, we get f of x equal to 8. When x is equal to 5, we get f of x is equal to 5. When x is equal to 6, we get 0. If we look at our plot here, we see where we actually could have just read the table. So at 0 it's 0, at 1 that's equal to 5, at 2 that's equal to 8, 9, 8, 5 and 0. So we get the same values if we just read it from the table as opposed to worked it out. But again, this is a very quick question. There's only part A and B, so we've lots of time to play with. So we just entered in those values into the table, and that's part A done. Part B says use the trapezoidal rule to estimate the area. So now we just apply the trapezoidal rule. Well, trapezoidal rule says the area is equal to the width over 2 times the first height and so I'll say initial height and the height of the final thing, and then the other ones multiplied by 2. So I need to know what the width is. Well, the width is equal to 1 here, because we work out we evaluate the function at 0, 1, 2, 3, and so on. So width is equal to 1. So now I just work this out. So that's a half. The initial thing is 0, and the final one is 0, which makes it easier. So 2 multiplied by 5, 8, 9, 8, 5. Because they're that's the value of the function, the height of the area for the 5 vertices. So now we just need to add that up. Well, I have a half and I have a multiplied by 2, so actually these cancel. So I just need to add these up. So the area is equal to, well, 5 plus 5 is 10, 8 plus 8 is 16, plus 9, 9 plus 16 is 25, so that's 10 plus 25, and that's equal to 35. So now just check, is that it? Use the trapezoidal rule to estimate the area of the region enclosed, and we've done that.